Today we will discuss about the particle size distribution of soil using hydrometer according to ASTM 7928. First of all, scope of the test. It means that this test method covers the quantitative determination of the particle size distribution of the fine grained soil portion. Normally this test is performed on material passing number 10 sieve or 2 mm or finer sieve, and the results are presented as the mass percentage finer of the fraction versus logarithmic scale of the particle size diameter. Normally after the calculation we have to prepare a logarithmic graph on which we have to represent the test data. This test is based on the Stokes law. The sedimentation of the particle size analysis is based on the concept of larger particle will fall through a fluid faster than the smaller particles. So all the test is based on the Stokes law. Here some points are provided regarding the Stokes law. Application of the test. Normally this test method is not applicable for the following soils. First of all, soil containing fibrous peat. Second is that if we have to perform a sieve analysis, as in my previous video you can see that approximately 5% fine grained material should be in the soil sample, or less than 5% it not be applicable for the performance of the test. Soil containing organic matter such as oil, asphalt and other items is not applicable for hydrometer test. On the other hand, material like soil stabilization admixtures used like cement, fly ash is also not applicable for hydrometer test. Significance and use. Significance and use is normally the purpose of the test. For what purpose we perform this test? Normally it is used for the gradation curve and for purpose of the classification. When we have to classify the soil, we need amount of silt and clay particles present in our soil sample. For this we have to determine the amount of silt and clay for classification purpose, and other engineering properties like hydraulic conductivity, compressibility and shear strength, etc. Apparatus use. Apparatus use for the hydrometer test is normally hydrometer. According to ASTM, there are two types of the hydrometer. One is 151H and other is 152H. Sedimentation cylinders or glass cylinder. Separation sieve, that is number 2 mm diameter or number 10. Thermostat, weight balance, near least count 0.01 gram, oven dry and other, as you can see here. Reagent and materials. Reagent. Normally sodium hexametaphosphate is used as a dispersing agent to avoid the deflocculation of the soil in suspension. Normally 5 gram per liter will be used for the hydrometer test. That is our reagent. This is sample preparation. How we prepare our soil specimen or sample for the hydrometer test. There are two methods for preparation of the soil specimen. First is moist preparation and second is dry preparation. Normally moist preparation is a referee method and preferred method. In this we will take a soil sample in moist form and obtain its moisture content passing number 10 sieve and prepare our soil sample. On the other hand, second method is air dry method, which is not preferable. It is permitted only when we have received the soil sample in air dry condition. For that purpose, if we have a soil particles greater than number 10 sieve, we have to break up down by using the mortar or rubber tip pestle. Normally moist preparation is preferred method. There is an equation for preparation of the moist sample in which all the data is provided. M mist is equal to HC into 100 divided by percentage estimated number passing 200 into 1 plus W seized divided by 30. W seized is the moisture content near to 1%, where HC is the hydrometer capacity, that is for 45 for 151H and 55 for 152H. There is an example provided for the determination of the moisture based soil sample. Putting soil in suspension or preparing our soil specimen. First of all, the test specimen is placed in a 250 ml glass beaker and mixed with water and sodium hexametaphosphate as a dispersing agent, as we discussed earlier, 5 gram per liter. The slurry is rinsed into a dispersion cup for agitation with the stirring apparatus for 1 minute. An alternative air jet device is permitted as per ASTM, but this apparatus is not available, then tipping point method or manual shaking is permitted. There is tipping method described. We can, if we have not the air jet available, then we perform by tipping method. Hydrometer calibration checks. When we have to perform the hydrometer test, there are some calibration checks that we must have to determine before performance of the hydrometer test. First of all is meniscus correction. Meniscus correction, normally when we use the hydrometers are designed to read the fluid surface. However, being wetting of the glass such that the soil is in suspension will raise the hydrometer marking or reading at the fluid surface. The meniscus raise has a small impact on our effective depth determination, so that meniscus correction is compulsory before performing the hydrometer test. You can see here there is a stamp of the hydrometer and meniscus is occurring. There is a top of meniscus and bottom of the meniscus. We have to read the top of meniscus and bottom of meniscus. The difference between these two readings is the meniscus correction that will be used in our further calculations. Second one is volume of the hydrometer bulb, VBH. We have to determine the volume of the hydrometer bulb. There are two methods. First is direct method and second is indirect method. Direct method is performed. We have a measuring cylinder up to 1000 ml and having minimum sensitivity scale 5 ml. If not available, then 10 ml may also be used. We have to fill the measuring cylinder up to 800 or 900 ml. It's up to your own choice, preferably 900 ml. Then insert the hydrometer in the water. There will be a rise in water due to insertion of the hydrometer. This rise in the water is the volume of the hydrometer bulb. We will be note this volume that will be used in our calculation. Second is indirect method. Normally indirect method is used by using a measuring cylinder, weight on the weight balance. We have to take the measuring cylinder filled with water and place it on the weight balance, having the least count 0.1 gram. First of all, we will place the measuring cylinder filled with water on the weight balance and tear the reading to 0. Then after that we will insert hydrometer in the water and up to the stem of the bulb of the hydrometer and note the weight of the hydrometer bulb in water at the weight balance. This will be the weight of the hydrometer. Then by using the density of water, that is 1 gram per centimeter cube, we can determine the volume of the hydrometer bulb according to indirect method. Then effective depth, that is crucial part of the calculation. The effective depth is also referred as a true depth, is used in the calculation of the particles fall distance for each reading that will take in the sedimentation cylinder by mixing the soil and dispersing agent. There is an equation provided that will help us to measure the effective depth. In that there is HM, that denoted to the hydrometer, HR2. Further we will discuss the HR2 and HR1, and HR1 minus HR2 divided by R2 minus R1 into R2 minus RM. RM is the reading of the hydrometer that we will take during our test performance, and CM meniscus correction reading, VHB, that earlier we discussed about that, volume of the hydrometer bulb divided by 2 into AC, cross sectional area of the measuring cylinder. This is the description of this equation. Here we will discuss about HR1 and HR2. HR1 is normally the distance between center of the bulb to the maximum level of the hydrometer, that is R1. You can see here, that is R1 and that is R2. In this picture you can also check there R2 and R1. In case of hydrometer 151H, we will use R1 is equal to 0.995, and in case of 152H hydrometer, our R1 value will be -5. And on the other hand, R2 in case of 151H 1.308, and in case of 152H it is 60. We have to measure the HR1, that is the distance between top of the meniscus scale up to the center of the hydrometer bulb. We will measure it by using the measuring scale or vernier caliper, preferable, which is available to you, same as center of the bulb to the stem of the bulb that is connecting to the hydrometer scale, that is our HR2. On that basis we will find out the effective depth measurement as we discuss here. Then the temperature density correction. During the performance of the hydrometer test, we have to measure the temperature value. For that purpose, we have to check the temperature density correction. During a test, the suspension fluid density changes. Therefore, calculation for the particles in suspension must count for fluid density change due to temperature and presence of dispersant and meniscus rise. There are two ways to determine this correction. First is take the companion measurement in control fill cylinder with the reference solution. Second is that calibration relationship, hydrometer readings of the control cylinder filled with the reference solution. What is the reference solution? Normally the reference solution shall be preferred with the same amount of dispersant as we discussed, 5 gram per liter as used in the soil suspension. Fill the control cylinder up to 1000 ml mark with the mixture of the test water and the same amount of dispersant used in the soil in suspension. The test water or dispersion shall be mixed thoroughly and used for our temperature density correction as per companion measurements or calibration relationship. Companion measurement. Position the hydrometer control cylinder filled with the reference solution in the same temperature controlled location as the test cylinder of our soil, so that all the cylinders are at near to the same temperature. For each hydrometer and temperature reading taken in the soil in suspension cylinder, take a corresponding hydrometer and temperature reading in the control cylinder that is filled by reference solution. However, it is possible that we can use 30 up to 30-minute readings of the hydrometer in the control cylinder that is filled in the reference solution and soil in suspension. Second is our calibration relationship. This operation generates a general calibration relationship between the hydrometer reading of a control cylinder filled with the reference solution and the temperature, which eliminate the need for the companion measurement during the test. Normally this relationship have an extra edge on the companion measurement. A temperature based general calibration relationship is required and established for each hydrometer. A sedimentation cylinder is filled up to 1000 ml marked with the test water with the same amount of dispersant or reagent 5 gram per liter as discussed, used in the soil in suspension. Be sure the solution is thoroughly mixed and temperature is allowed to equilibrate. Then we insert the hydrometer as described in the procedure and take the hydrometer readings that are our used for measurement of the constant value of constant A and constant B that will be used in later in our equations. Then procedure. How we will perform the hydrometer test. First of all, as we discussed, we will prepare a soil specimen by using 100 ml water with 5 gram sodium hexametaphosphate and place our soil specimen into a agitation cup. Then we will mix this sample with an agitator for a period of 1 minute. After mixing the specimen, we will pour our sample into a 1000 ml and our 1000 ml jar will be filled by a test water or distilled water up to 1000 ml mark. Then we will shake the sample as discussed, air jet or tipping method or manual method, which is suitable. Then the cylinder is placed back on the bench or on a constant temperature bath if available, and check to see if a foam on the top of the suspension will inhibit accurately reading the hydrometer. Take the reading of hydrometer in suspension of measuring cylinder at elapsed time of 1, 2, 4, 15, 30, 60 up to 24 hours or 14-40 minutes. Additional readings are optional or up to you. If you want to take additional readings for your requirement, you can take. Then read the meniscus on the top of the hydrometer as we discussed earlier, that part will be used in the meniscus correction. Extract the hydrometer on steady motion and take 5 to 10 seconds to remove it. If there is a drop of liquid remaining on the end of the bulb, touch the lip of the sedimentation cylinder and let it flow back into the suspension. Means to say that there is no particle should be stuck on the hydrometer. Immerse the hydrometer into the cylinder of a clean water and give it a spinning motion to clean for the purpose of cleaning. remove and dry before taking the next readings. After each hydrometer reading, insert the hydrometer without disturbing the suspension and record the temperature reading. Once the hydrometer reading has been taken, transfer all the soil in suspension into an oven drying container, or after drying or before drying we can perform the wash sieve to note the weight of material retained number 200. If dry mass is required, as later on we will discuss in the calculation, we require the dry mass, we will use the wash sieve number 200 and wash the material on number 200 sieve until the clear water has been occurred. The running of the clear water will indicate that there is no further soil particles that are passing from number 200 wash sieve. This is the procedure. Now we will go to the calculations. Temperature density correction. As earlier we discussed the temperature density correction. We have to take the hydrometer reading in the reference solution that we discussed. That is our value of the hydrometer reading in the reference solution that will be used for to measure the value of constant A and constant B. There is constant A and constant B. Here is constant A. We will calculate the value of constant A on the basis of R51T if we are using 151H hydrometer. 151T is the reading of the hydrometer in our reference solution for the temperature density correction. On that basis we will measure the value of A. Same as we will measure the value of B that will be used for temperature density correction if we are using 152H hydrometer. R52 is the value of the reading of hydrometer in reference solution filled with water and dispersion agent. This is our R152 and T is the temperature of our particular reading at that time. On that basis we will calculate the RDM, that is our offset reading. This is a reading that we will further calculate our percentage passing. We will have to calculate RDM for 152H and RDM value for 151H on the basis of constant value A and constant value B. After that, first of all we have to calculate the dry mass using the moist mass and water content. For that purpose we have the equation. On that basis we will calculate the dry mass using moist mass and water content. This is because we are using moist preparation sample and we have to calculate the dry mass. For this purpose we will use this equation. If we are using dry mass method, then we will use this equation. Percentage finder for 151H. As earlier we discussed the temperature density correction, we have to find out the percentage of our particles passing, that Nm denoted to mass percentage finder, Gs is the specific gravity of soil, Vs is the volume of our hydrometer cylinder or our sedimentation cylinder, that is up to 1000 ml, Md mass of dry soil that we have to calculate by moist mass method in the first sample, first equation. Then density of water, Rm will be the hydrometer reading for the particular time, that is 1 minute reading, 2 minute, 3 meter and so on. each hydrometer reading denoted by RM. RDM, as we calculate by this equation, we will use RDM value and into 100. On this basis, we can calculate the hydrometer readings percentage passing. This is the equation that will be used for the percentage passing if we are using 152H hydrometer. Same RM and RDM. RM will be the hydrometer reading at a particular time, 1 minute, 2 minutes and so on. RDM, that will be temperature density correction reading, that earlier we have discussed on the basis of constant B. We using the constant B and calculate the RDM value, and using this equation for 152H we will find out our percentage passing. Diameter of the particles in suspension we can calculate by this formula. You can read that equation. After that, percentage passing number 200 sieve, by using this equation we can find out the percentage passing. MDR is the initial mass, MDR is the mass retained on number 200 sieve after washing and dried in an oven, where MD is the initial dry mass of the sedimentation specimen without dispersing agent. This is an example report sheet in which we have calculated the sample measurement, effective depth measurement and hydrometer calibration data for 151 and 152H, that is R1, HR1, HR2, R2, HR2, meniscus correction, number 200 after passing number 200 wash sieve data, and the hydrometer readings are provided there. On that reading, on the basis of that reading, we will find out our percentage passing in the tabular form and draw a graph on which basis we can find out our CU, CM, coefficient of uniformity, coefficient of curvature, etc. That will be used in our further calculation of soil classification. Now we will go for the performance, practical performance of the hydrometer test.
Today first we measure the volume of the hydrometer, VPH. There are two methods for determining the volume of the hydrometer. First is direct method and second is indirect method. In direct method, we have a measuring cylinder, minimum least count of 5 ml, and having the water volume in this cylinder is 900 ml, that you can see there. This is our hydrometer. For indirect method, we will insert the hydrometer into the water up to the stem of the hydrometer bulb and record the rays of water in the measuring cylinder. At that time it is 60, so that we can say that the volume of the hydrometer is 60. For that purpose, there is 900, 10, 20, 30, 40, 50 and 60. Up to that, there is the volume of the hydrometer bulb as per direct method by volume method. Second is indirect method. For that purpose, we have another cylinder having the volume 1 62 ml. We will place this cylinder on the weight balance and tear the volume or the weight of the water in the measuring cylinder. After that, we will insert the hydrometer up to the stem of the bulb that you can see here and note down the weight of the hydrometer on the weight scale, that is 59.89. This is the indirect method by weight method, and another is direct method in which we can find out the volume of the hydrometer bulb. We will find out the hydrometer effective depth HM that will be used for the hydrometer calculations. You can see that there is a scale along with the hydrometer. There is mentioned R1 and R2. R1 is the hydrometering reading. In case of 151H, that will be 0.995, and in case of hydrometer used 152H minus 5, as well as R2 in case of 151H 1.308, and in case of 152H there will be 60. With the help of the scale, we will measure the effective length, that is HR1, that is 1.965, and HR2 8.25 centimeter. Now we will find out the volume of the hydrometer bulb. For you can see that there is a volume of water near 900 ml. Now we will insert the hydrometer up to the stem of the hydrometer bulb. The raise in the volume of the water from 900 to the graduation mark on the cylinder we will note down, that is near about 60. This is the volume of the hydrometer bulb up to the stem of the hydrometer bulb, that is 60 centimeter cube. This is the volume of hydrometer bulb by direct method. Now we will go for the indirect method. For indirect method, we will place the measuring cylinder on a weight balance, that is the weight of the measuring cylinder filled with water before insertion of hydrometer bulb. After that, we will insert the hydrometer up to the stem of the hydrometer bulb and note down the weight again. This is our indirect method for hydrometer bulb. After that, we have to prepare our soil specimen cylinder and reference solution cylinder for hydrometer readings. For that purpose, there is an cylinder filled with plain water and the other cylinder filled with distilled or plain water mixed with 5 gram per liter hydrometer sodium hexametaphosphate for hydrometer reference solution. First of all, we will measure the quantity of sodium hexametaphosphate that will be used for reference solution. This is the weight of sodium hexametaphosphate, that is 5 gram used for the reference solution. As earlier, we already prepared a solution for soil in suspension or soil mixing. Now here is our 100 ml water. We will add 5 gram of sodium hexametaphosphate into the 100 ml solution. Now with manual mixing, we will mix all the solution and prepare our reference solution cylinder. As you can see that there are 3 cylinders. First one is plain water cylinder, second one is reference solution mixed with 5 gram per liter, and third one is our soil specimen cylinder. We have a soil mixed with 100 ml solution. As earlier we already had the mixture of the soil. Now we will pour this soil to our sedimentation cylinder up to 100 ml. Before starting the test, we have to take the meniscus reading in a plain water cylinder, as you can see here. By placing a white paper behind that, you can take the meniscus reading. In our case, the top of the meniscus is 3 and bottom is 2. So we can find out the meniscus reading, that is equal to 1. 3 minus 2 is equal to 1. Now you can see there our reference solution cylinder and soil specimen cylinder has been prepared and ready for the hydrometer readings. We have to turn on the stopwatch and take the hydrometer readings in the sedimentation cylinder mixed with soil, and corresponding readings will be taken in the reference solution cylinder, that is in the middle of those two cylinders. We will take the R152, that we are using 152H hydrometer. As we will shake the sample manually by tipping method, for that purpose we have a rubber stopper at the top of the measuring cylinder and shake our soil sample manually. Keep in mind, there should be no loss of soil specimen during the mixing. Now we will start taking the hydrometer readings. The reading is near. You can see hydrometer is floating 30. At 30 seconds, the reading is 33. We will note it down on our table. After taking the reading, we will put our hydrometer into a plain water in a spinning motion, that the soil particles stuck on the hydrometer will be washed out, as well as we will start taking our reference solution reading in the reference solution cylinder that will be used for temperature density correction. As you can see that it is near 4, that is our reference solution reading at 30 seconds. Now we will take the reading of 1 minute. That you can see that 30 is near 32. We will note it down. This is our data recording. With the help of thermometer, we will note down the temperature reading into a soil specimen cylinder. Be careful that should be no disturbance, that the soil in suspension it is near to 34 degrees Celsius. We will also take the hydrometer reading in a suspension cylinder. That is also near to 34 degrees Celsius. Now we will take 2-minute reading into a hydrometer in a soil suspension cylinder. That is near 30, we can say 30 on 2-minute reading. Now we will place the hydrometer into a plain water in a spinning motion as described, and then take the corresponding offset reading in a reference solution. Same it is previous 4. Our offset RDM value calculation reading is 4. Now we will take temperature reading in a soil suspension. As you can see, it is 33. We will take the reference solution cylinder temperature reading. Same, it is 33. Now we will wait for the 8 minute, 15 minute, 30 minute and 16 minute reading. When the time will 8 minute, then we will take our 8 minute reading and so on. We will measure our hydrometer readings at the different time of interval as prescribed earlier. We will place a rubber stopper at the top of the soil suspension cylinder to avoid any evaporation for the given period of time for next reading. Now we will take the 8 minute reading. For that purpose, we will place our hydrometer 10 to 15 seconds before 8 minute reading. Gently place the hydrometer into a soil specimen cylinder and wait for its equilibrium, and then take our hydrometer reading. That is near 23. We will place hydrometer in a plain water in spinning motion to clean it out, and after that we will place in a reference solution cylinder for temperature density relationship correction and take the hydrometer reading, that is 4. Now again we will measure the temperature of soil specimen. As you can see, it's 34, as well as we will measure the reference solution temperature, that is also near 34. So as we will measure our remaining reading at required interval of time, that is 15 minutes, 30 minutes, 60 minutes, 240, and 40. Now we will take the 8 meter reading. That is near to 19. So that we can say our 8 minute reading is 19, and we will take temperature reading in reference solution cylinder, that is 34, in soil suspension solution, that is also 34. We will take our offset reading in reference solution cylinder, that is 4. This is our offset solution cylinder reading in the reference solution. We have taken all the readings up to 24 hours, and as you can see that hydrometer has been settled up to 9. That is our 24-hour reading. After that, we will place our hydrometer in a plain water, and further we will pour this solution on number 200 sieve for washing purpose and to determine the material retained on number 200 sieve. Here is our number 200 wash sieve. By using this sieve, we will wash out our sample and determine the weight retained on the wash sieve. You can see that material that was settled down is tucked into the measuring cylinder. Now we will wash this material and place it on the wash sieve for washing purpose. We will wash our sample on a wash sieve, as you can see here, until that clear water that you can see is not running through the washing sieve. You can see that the material retained on the number 200 washing sieve. You can see that there is a clear water running from the wash sieve, so that we can say that this is our end of the experiment. Now we will place this material in the oven for determination of the weight retained on number 200 sieve after performing the experiment. Thank you. Here it is, weight of wet soil retained on number 200 sieve plus sieve. After that, we will place into a oven at constant temperature of 110 plus minus 5 for 24 hours. This is our table of readings that we noted during the performance of the test. Now after 24 hours, we will note down the weight of wet soil for moisture content and weight of soil retained on wash sieve. The sample is placed in the oven for 24 hours. After 24 hours, we will note down the weight of dry soil in wash sieve number 200. After 24 hours, weight of dry soil plus container is 28.77 gram. That is the weight we have to determine for the moisture content. At the start of the test, we place this in the oven for 24 hours. After 24 hours, weight of dry soil in the number 200 sieve is near about 5.91 gram. That is the weight of dry soil into the wash sieve. As you can see, 5.91 gram of soil retained on number 200 sieve after washing at the end of the experiment.